Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaram. Students, today we are going to discuss the very important topic in the physics, that is heat and temperature. Heat and temperature. Okay. So let us start the session. Yes. Heat. You know very well what is the heat in general terms. Sensation of warm. Okay, that is warm sensation is nothing but you can say heat. Correct. If you touch any object, if you feel warm, then you can say it is very heat. Okay, so we can write down this one. Heat is nothing but sensation of warm. Okay, or warm sensation. Warm sensation. And this heat is nothing but one type of energy. Okay, it transferred from higher the temperature to lower the temperature. So it is energy, na? So energy units you know very well. So you can denote as the joules or calories. Okay, so heat is form of energy, which flows from high temperature to low temperature. Low temperature when they are contact each other. Okay, so we know very well in the previous session we have discussed in detail current. Current flows from high voltage to low voltage. That means high potential to low potential. Okay, so if you can consider current, current flows from high potential to low potential. Correct? In the same way, current flows from high voltage to low voltage. In the same way, if you can consider water. So water also flows from higher the pressure. If the pressure is high here, if the pressure is low here, okay. So water flows from high pressure to low pressure. Okay, water flows from high pressure to low pressure. Okay, and in the same way, if you can consider magnetic flux, higher the mmf, high mmf to low mmf. Okay, so if you can consider any quantities generally flow from higher to lower side, Here also heat, for example, if here one body is having 100 degrees centigrade, another body is having 50 degrees centigrade. Here what is happening? Heat flow takes place from high temperature to low temperature. High temperature to low temperature. So you can note down heat is a form of energy which flows from high temperature to low temperature whenever those two are intact or in contact of each other. Okay, and we know the SI units. SI units of heat is nothing but joules or kilojoules. And if you can consider practical units are calories. calories. Okay, and you know very well the relation 1 calorie is equal to 4.18 joules or 4.2 joules. So calorie is the bigger unit than joule. Okay, bigger unit than joule. So if you can consider 1 joule is equal to 0.24 calories. Okay, we have other units are also there. Some other units are also there. Let us take a British thermal unit, BTU. 1 BTU is equal to 252 calories. So from this one, we can say B2U is the highest unit. Okay. So these are the important units of the heat. Heat units and temperature units are different. Temperature, we have Celsius, Fahrenheit, Kelvin, all those. Heat, joules only. SI units are joules. In case of practical units, calories only. That means you can say heat is the form of energy. All the energy units are units of heat also. Okay, now coming to the temperature. You know very well what about the temperature. So if we say the temperature is 50 degrees Celsius, then we can say that is very hot. If we say temperature is 22 23 degrees centigrade or 20 degrees centigrade, we can say the atmosphere is very cool. That means temperature will give the idea how much hotness, how much coolness. Okay, so it is nothing but it is the degree of hotness or degree of coolness is nothing but temperature. All of you getting? Heat is nothing but energy. Okay, it gives the sensation of warmth. It temperature is nothing but which decides or which gives the degree of, that is how much of hotness, how much of coolness. Okay, so you can note down which expresses the degree of hotness or coldness. Hotness or coldness. Okay, coldness of object or body, any body or object. Okay, so whenever there is a temperature difference, then only heat flow takes place. Just now I said na, whenever there is a temperature difference, okay, that means high temperature to low temperature it is flowing. Whenever there is a temperatures are same, there is no heat flow takes place. Okay, so can note down here, heat flow takes place whenever there is a temperature difference. There is temperature difference. Okay, if there is no temperature difference, if there is no temperature difference, okay, if there is no temperature difference, heat flow may not take place. May not takes place. Heat may not flow, or heat flow may not takes place. Okay, for example, if we have the two objects, object A, object B. Here object A is at 100 degrees Celsius, object B at 50 degrees Celsius. Then heat flow takes place. Heat flow takes place. Okay. Second example. Let us take if object A at 27 degrees centigrade, object B also at 27 degrees centigrade. Then what will happen, guys? Then heat flow takes place. For example, 27 degrees centigrade is considered as a room temperature. If the two objects, for example, if you place one box, one pen at room temperature, then is any heat flow takes place? No, both are at same temperature. So here heat flow not takes place. Okay, heat may not flow. The heat may not flow. So if we want to flow the heat, there must be a temperature difference. If you want to flow the current, then voltage difference is needed or potential difference is needed. If the water wants to flow, there may be height difference or pressure difference is needed. Okay, so water flow from higher the height to lower the height, or if you switch on the pump, then pump creates the pressure difference. Then also whenever there is a pressure difference, water is flow. Whenever there is a mmf difference, magnetic flux is flowing. Okay, so difference is needed. Difference is needed. Okay, so here the two important points: heat flow takes place whenever there is a temperature difference. If there is no temperature difference, there is no heat flow. Okay, that is a very important point here. Now the temperature of body is generally measured by a thermometer. Okay, thermometer. Temperature of body is measured by thermometer. Okay, the liquid used in this thermometer is mercury. Mercury is used. Okay, nowadays we have electronic thermometer, that is I am not saying. So previously we have liquid thermometers, now mercury thermometers. This mercury thermometer is invented by the scientist Evangelista Torricelli. Mercury, very important question. Mercury thermometer invented by the scientist Evangelista Torricelli. Maybe some spelling mistakes. Forget about those. Evangelista Torricelli. Okay. The name of his name Tar, that is one of the unit of atmospheric unit, 1 ATM. Okay. So temperature of body is measured by thermometer, and we have so many temperature scales are there. So many temperature scales are there. So Celsius, after that Fahrenheit, Kelvin, Reaumur, Rankine. Okay, so before going to discuss all those temperature scales, I want to give idea about freezing point and boiling point. Okay, so freezing point. Freezing point. What is the freezing point? It is also called as ice point. Ice point in the sense, as in the name itself, the temperature at which water will becomes ice. Okay, temperature at which water becomes ice. Okay, that is liquid becomes solid. Okay, and the second one, boiling point. Boiling point. Okay, it is also called as steam point. Steam point. As the name itself, water becomes steam. Temperature at which water becomes steam is called as boiling point. Okay. So now we are going to discuss different temperature scales. Different temperature scales. Different temperature scales. Okay, we have 5 types of the temperature scales. I want to give all those. Coming to the first one, Celsius scale. Celsius scale. Okay, so the Celsius scale starts from 0 degree Celsius, 0 degree Celsius to 100 degrees Celsius. This Celsius scale starts from 0 degree Celsius to 100 degree Celsius. So it has divided into 100 equal parts. Almost 100 equal parts. Okay. So it is initially known as centigrade scale. Centigrade scale. Here freezing point. It is the freezing point. Freezing point. That means at which the water will becomes ice. So freezing point is 0 degree Celsius. 100 degree Celsius is considered as boiling point. Boiling point. Okay. Divided into 100 equal parts. Divided into 100 equal parts. Okay. Now coming to the second one, Fahrenheit scale. Fahrenheit scale. Okay, coming to this Fahrenheit scale, it starts from not 0 guys. It starts from 32 degree Fahrenheit and ends at 212 degree Fahrenheit. Okay, so 32 to 212 means approximately how many parts? 180. So it divided into 180 equal parts. Divided into 180 equal parts. What is the freezing point? Freezing point is nothing but 32 degree Fahrenheit. Boiling point FP, this is the baby. Boiling point is 212 degree Fahrenheit. The third one. What is the third one? Third one, very important. Kelvin scale. Kelvin scale. If you can consider SI unit of temperature, that is Kelvin only. SI unit of temperature, that is Kelvin only. So it is starts from 0 Kelvin? No. Starts from 273 Kelvin to 373 Kelvin. Okay. So it has how many equal parts? 100 equal parts. 100 equal parts. Okay. The fourth one is Reumer scale. Reumer scale. Very, very rarely used. Okay. It is 0 from 80. It starts from 0 Reumer to 80 Reumer. 80 Reumer. R for Reumer. Okay. And fourth one, Rankine scale. Sorry, fifth one, Rankine scale. So it starts from not 0 guys, 460 degrees RA, 460 RA to 460 RA to 672 RA. So total how many? 460, 560, 660, that is 210, 212. So 212 parts. Okay, RA means Rankine. So these are the 5 scales we have. In these 3, first 1, 2, 3 are very important. First 1, 2, 3 are very important. Okay. So coming to, is there any relationship between these temperature scales? Yes, we have. From that relation, we can convert any one scale to another scale. Any one scale to another scale. Okay, these are same like in our India, currency is in rupees. In America, dollars. Okay, so like that, here some countries are using Celsius, some countries are using Fahrenheit, like that. So we know very well $1 is approximately 85 to 90 rupees. In the same way, here there is a conversion between these temperature scales. Okay, let us take that one. Before going to take the that is relation between those, I want to give all these in the tabular form. Freezing point, boiling point. Okay, if you can consider Celsius scale, Fahrenheit scale, third one Kelvin scale, Römer scale, Rankine scale. Okay, so in case of Celsius scale, freezing point is 0, boiling point is 100. Am I correct? 0 degrees Celsius, 100 degrees Celsius. Fahrenheit, 32 degree Fahrenheit, 212 degree Fahrenheit. Kelvin, 273 starts from 273 Kelvin and ends at 373 Kelvin. So that is, this is the freezing point, this is the boiling point. 0 Römer, 80 Römer. Here 460 RA, 672 RA. Correct? Now I want to take the relation between all these. Relationship between various temperature scales. Various temperature scales. Okay. Now I want to make all the numerators are equal to 0. Equal to 0. Okay. First of all, I am going to make C is equal to 0 in the numerator. If you take a, just these are some trick to remember only, numerator. Okay, making equal to 0. C is equal to 0, Fahrenheit is equal to 0, Kelvin is equal to 0, Römer is equal to 0, RA is equal to 0. So then only we can get all are equal to 0 now. So that means here in the Celsius, C it is also 0 means we can make it as C. Here we are making Fahrenheit as a 0, that means F minus 32 is equal to 0. Here K minus 273 is equal to 0. Here R minus 0 is equal to 0. RA minus 460 is equal to 0. Okay, these are the freezing points now, correct? Here what I am doing is I am making the first ones are equal to 0. So how can make first one is equal to 0? Generally here F is equal to 32 means F minus 32 is equal to 0 now. Here F is equal to 32, we have the freezing points. K is equal to 273, we have. R is equal to 0, we have. RA is equal to 460, we have. Correct? Okay. Correct? All of you clear? So I am taking the first line, freezing points. Freezing points. The freezing points 0, 32, 273, 0, 460. Okay, Celsius is equal to 0, Fahrenheit is equal to 32, Kelvin is equal to 273, R is equal to 0, RA is equal to 460. How to get the 0? If you send 32 this side, F minus 32 is equal to 0, K minus 273 is equal to 0, R minus 0 is equal to 0, RA minus 460 is equal to 0. So, if all are equal to 0 means we can make all them as equal. Yes. Okay. C equal F minus 32 equal K minus 273 equal R equal RA minus 460. Okay. So, but what is the problem here? Here there is a difference in the boiling points and the divisions also different. Here 100 divisions only. Here 180 divisions. Okay. Here what is the difference in this? Here 100 divisions. Here how many divisions? 180 divisions. Here again 100 divisions. Here 80 divisions. Here 212 divisions. So divisions are different. So we have to divide those divisions. How many divisions it has? It has 100 divisions. It has 180 divisions. It has 100 divisions again. It has 80 divisions. It has 212 divisions. Okay. Now I want to divide all these with one suitable value. Okay. So what is the one suitable value? We can divide all these. Let us take 20. So if I divide with 20, if I divide with 20, so denominator only I am dividing. So with 20, divide denominator with 20. 25s, 29s, 25s, 24s, 20, 10.6. So finally what is the relation we got? C by 5 is equal to F minus 32 by 9 is equal to K minus 273 by 5 is equal to R by 4 is equal to RA minus 460 by 10.6. It is the relation. Okay, it is the relation. Try to remember this relation. If you forgotten also, you can write all this and you can get the relation. Okay, but try to remember. Okay, in the examination, though we don't want to waste the time. Correct. So, if you can consider the relation between these two, Celsius and Kelvin, Celsius and Kelvin, Celsius and Kelvin, it is a very important. T by 5 is equal to K minus 273 by 5. Okay, so that means 5 is cancelled out. So we can say degree Celsius is equal to Kelvin minus 273. Very important. If you want degree Celsius, if you have only Kelvin, if you want degree Celsius, you can use this relation. You can use that relation. Or if you want Kelvin, send this 273 to that side, then degree Celsius plus 273. Okay, all of you getting? For example, if you have 27 degrees Celsius, they have given Celsius 27 degrees centigrade Celsius, asking Kelvin is equal to dash. In Kelvin is equal to dash. So we have Kelvin in Kelvins is equal to degree Celsius plus 273. Degree Celsius they have given 27 plus 273. That is 300 Kelvin. 300 Kelvin. So like that you can easily get the idea. You can easily get the idea. Okay. So if they have given Kelvin is equal to 310 Kelvin, asking degree Celsius is dash, then how to get from this? Degree Celsius is equal to K minus 273, that is 310 minus 273 that is 37 degrees Celsius. 37 degree Celsius. Okay, 37 degrees Celsius. In the same way, if you want to get the relation between degrees Celsius and Fahrenheit, that is C by 5 is equal to F minus 32 by 9. From that you can get. Okay, we have one question, very important question. At what temperature Celsius and Fahrenheit are equal? Sometimes we are getting the question, at what temperature Kelvin and Celsius are equal. At what temperature Kelvin and Celsius are equal. So if you want to make the equal, C by 5 is equal to, sorry, not Kelvin, Fahrenheit and Celsius are equal. And Celsius are equal. C by 5 is equal to F minus 32 by 9. So if you want to make all are equal means Celsius is equal to Fahrenheit is equal to, you can take any X or Y or Z or whatever it may be. Okay. I am taking the X means in the place of C, I am taking X. In the place of F, I am taking the X. Okay. Correct. C is equal to F is equal to X. Then only equal now. So from this 9x is equal to 5x minus 160 now. So from this 4x is equal to 160, x is equal to 40. So at 40, both Celsius is equal to Fahrenheit. Okay, at temperature 40, Celsius and Fahrenheit both are equal. So that is nothing but the temperature is nothing but 40. So like that you can get the idea. Okay, and here Kelvin scale starts from 273 to 373. Okay, so that is lowest possible temperature. Lowest possible temperature is called as absolute temperature. Absolute temperature. Okay, absolute temperature. That is lowest possible temperature is nothing but 0 Kelvin. That is temperature. That is 0 Kelvin. Okay, that means there is no negative value in the kelvins. There is no negative temperature in Kelvin scale. Okay, so maximum possible that is lowest possible temperature is 0 Kelvin only. So it is the lowest. So there is no negative temperature in the Kelvin scale. Okay, at this 0 Kelvin, molecular motion is ceases. Molecular motion ceases. That means the kinetic energy becomes 0. There is no movement. There is no movement of molecules. The temperature is also called as absolute temperature. Absolute temperature. Okay. Now, after this, we are going to take some important points in different temperature scales. Let us take the temperature, degrees Celsius, Fahrenheit, and Kelvin. These are the very important 3 scales. Okay, let us take normal temperature of body. You know very well about this. Okay, what is the normal temperature of body? In Fahrenheit, you know very well. So 98.6 Fahrenheit. If you convert it into a degree Celsius, it is approximately 37 degrees Celsius. If you know 37 degrees Celsius, Kelvin is nothing but 37 plus 273, 310 Kelvin. Okay. And normal room temperature, generally consider as normal room temperature, it is 27 degrees Celsius. From the place to place it changes, but generally we are considering 27 degrees Celsius. In case of Fahrenheit, it is 80.6 degree Fahrenheit. In Kelvin, 300 Kelvin. 300 Kelvin. Okay, these two are very, very important for exams. Okay. Okay, students, we will discuss the remaining in the next session. In the next session, thermal expansion in solids, liquids, and gases. Okay, after that, anomalous behavior of water, how the water is behaves in different temperatures. Okay, after that, Newton's law of cooling, and we will end the heat topic. Okay, students, if you want previous sessions, please click on the playlist and you can find out the previous sessions. And if you want PDF, you can download from the website sunilengineeringacademy.com. I will give the link in description box. You can download from that. Okay, students, if you like the classes, don't forget, please click on the like button and also please share to all your friends. Okay.